Alright, so here's the second video. This is half review from the last section and half review of last year. There's really one new concept in here that we're going to talk about. You guys should actually be able to do this warm-up because it was just in the section 311. So why don't you guys try to pause this, try to fill out this whole warm-up, and then unpause it, and we can go through it together. Alright, so assuming that you already tried to do this on your own, let's find the expression for the perimeter of the park. So it's talking about the park's in the shape of a triangle, which means it has three sides. Here's your three lengths, and remember, perimeter is just adding up your three distances. So the perimeter is going to be equal to the side length 8x plus the side length of 10x plus the side length of 11x minus 2. And no, you do not have to have parentheses. I'm just showing you that these are your three sides. If you combine your like terms, 8, 10, and 11 makes 29x, and then minus 2. So this expression is your perimeter, and they tell you that this is in feet. So perimeter is equal to 29x minus 2 feet. All right. What is the perimeter of the park if each fence panel is 4 feet long? So they're telling you that x is 4. So then that means we're going to do 29 times 4 minus 2, which equals 114 feet for the perimeter. Number 3, how does the perimeter change if the length of the side panels increase to 5 feet? So that means instead of 29 times 4, we're going to do 29 times 5 minus 2, and that actually gives 143 feet. So the question is, how does this change if we increase it? Well, we now have 143. We had 114. So we want to know how much we increased. Well, if we take our new length and subtract our old length, we get a difference of 29 feet. So that means that our perimeter is 29 feet longer. We're going to use this idea in today's section. All right. So your objective is that you can interpret parts of a given expression. So basically doing what we just did and talking about how one thing changes the whole answer of the expression. And then you guys are going to determine where a quadratic function is positive and where it's negative. This is kind of new. We talked about it last year. We just talked about it with linear functions, though, and not with quadratic functions, since this year's quadratic. It would be when we talked about something like this. So let's say that this is my linear function. Right here, if you remember back to last year, a function was positive and negative. So positive when your function was above your x-axis, and it was negative when it was below your x-axis. So this function is positive here, and it is negative here because, oops, you can't even see that. And it's negative here because that's where it's below your x-axis. So that's kind of hard to see with those highlighters. Let's see, let's try something else. So it's positive here for all x, for the x values that put my function above, and then it's negative for those x values. Right here, it's neither positive nor negative because it's on my x-axis, not above or below. So we'll talk about that. All right. Number 1, you guys should be able to do by yourself. It's review from the last section. So why don't you guys pause this and try to answer these questions. You're just multiplying this expression, which was what we did in Unit 1, and then you're identifying your values of A, B, and C, which we've been doing since the beginning of Unit 2. All right, so go ahead and pause it. All right, assuming that you guys already did this, when you multiplied here, you should have gotten 2x squared minus x or minus 1x. And when you multiplied here, you would have gotten 4x minus 2. When you simplify, you should have gotten 2x squared plus 3x minus 2. If we want to talk about what your terms are, you have three terms. They are 2x squared, they are 3x, and they are negative 2. So you guys should write that down. Your coefficients, I have 2x squareds and I have 3x's. They are the numbers in front of your variables. And then I have a constant of -2. Remember, your constant is the number that will never change. No matter what x is, -2 will always be -2. Okay? Alright, I'm going to skip down to here where it says, what are your values of a, b, and c? The value of a is 2, the value of b is 3, and the value of c is -2. So that just came from right here. A, B, C. Alright, so compare the resulting polynomial to ax squared plus bx plus c. This is just saying that they want us to show that it's quadratic because it can be written in the form of ax squared plus bx plus c. Again, right here, your ax squared term. Alright. So we're going to skip example 2 because that's the newer part, and we're going to go to example 3. It says the length of each side of a square is increased by 2 centimeters. How does the perimeter change and how does the area change? Well, we're talking about a square, and remember in a square, all of your sides are the same. So, if we have a square and we want to talk about the perimeter of a square means that we're going to do side length plus side length plus side length plus side length. So 4 side lengths, they're all the same, so that's the same as just saying 4x. And then the area is just multiplying your base times height or length times width, and because of the same sides, that means I can just say x times x or x squared. So if I increase my side lengths by 2 centimeters, that means instead of saying my side lengths are x, 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 and x, that means now my side length is going to be x plus 2. My next one is x plus 2. My third one is x plus 2. My fourth one is x plus 2. So if I want to find the perimeter, I can add up this 4 times, or I can just say this times 4. And then I can now multiply this, distribute. I get that my perimeter is 4x plus 8. So what I find out is that my perimeter, my new perimeter compared to my original perimeter, 4x and 4x are the same. I find out that my perimeter just increased by a length of 8 centimeters. And I can find this out like we did in our warm-up by saying, well, my new perimeter is this, and if I subtract my old perimeter, or my original, these cancel, and I find out that this is going to be 8 centimeters longer. So I increase the side lengths by 2 centimeters, which means my now answer of my perimeter is 8 centimeters longer. Okay? Alright, next, the area. So my area right now is whatever my length is, x, and if I square it, that's my area. So if I increase each of the lengths by 2 centimeters, that means my new side length is x plus 2, which means that I'm going to square that, because every side now is x plus 2, x plus 2, x plus 2. Or I'm going to do one of the side lengths, x plus 2, times the other side length of x plus 2. This is length times width. They're the same thing. So I find out that my area, if I multiply these out, is x squared plus 2x plus 2x and plus 4. Simplify, I get x squared plus 4x plus 4. So here's my new area because I increased my side lengths by 2. This is my old area. If you notice, the difference between this and this is really just that I added on this. So I can say that my new area is this. If I take away my old area, or my original, this is my original, again, I find out that the difference between these is that now I have a 4x plus 4. So all that means is my new area is 4x plus 4, this whole thing, centimeters longer. Just like we did in the warm-up, just like we did over here, this was 8 centimeters longer. And this area is going to be 4x plus 4 centimeters longer. Okay? You may want to go back and watch that again because I know it's kind of new and we're going to have some problems in our homework that are going to be like this. We are going to skip example 4. We're going to go back up to example 2, and we're going to do a couple of these. So, again, what this is saying is if you want to figure out what values of x make an expression positive or negative, it means we want to know what values of x make my function go above the x-axis and below the x-axis. So if here's your xy axis, we want to know what values make my function go up here. That's positive versus down here. That's negative. Okay. So what I really need to figure out is where my function lies on the x-axis, because that's then the turning point of where I will be above and below. Alright, so that means that anything on my x-axis is my x-intercepts. Notice that we've given this function to you in intercept form. We haven't seen the intercept form in a while, but remember, this is intercept form. So this tells you that this intercept is going to be at -2, and this one's going to be at +3. And that just is from doing x plus 2 equals 0 and x minus 3 equals 0. If I subtract 2, I find out that x is -2. If I add 3 to both sides, I find out that x is 3. Again, opposite of -3 is +3. Opposite of +2 is -2. Remember, your intercept form is... is y equals a times x minus p times x minus q. Remember, these minus p minus q is y. It's the opposite of +2, opposite of -3. So what you want to do is you want to draw yourself a little sketch of your xy axis. We're going to plot this quadratic function. So I know that I have an x-intercept at the x value of -2, so that's somewhere over here. I know that I have one at the positive x value of 3, so that's somewhere over here. I need to decide whether my function opens up or whether it opens down. This right here is going to give me a positive x squared, so that means a is 1, positive 1. So that means my function will be going up. So we know my function looks like this, just a sketch of it. I want to label where these x-intercepts are. So this one's at -2, and this one is at the x value of 3. Alright, so my function is positive when my function is above the x-axis. I want to identify which x values that is. So this is kind of like writing your domain. So my function is positive for the x value of this right here is above the x-axis, and this right here is above the x-axis. So there's actually two intervals, and we need to separate them. So this is coming from the x value of -infinity, and it's going to the x value of 2, and then it stops being above my x-axis. At -2, it's on my x-axis, so I do not want to include it, because right here it's not above. And then I also want to write this interval. Whenever we have two intervals, we need to combine them with a union. That's a U right there. It's called a union. This means I can combine intervals. It's also above this x-axis, starting at the x value of 3 to the x value of +infinity. Okay? So these are my two x intervals where I'm above, and then right here, from the x value of -2 to the x value of 3 is where I'm below my x-axis. So right here, negative. Again, this is always asking for what x values. So it's negative from the x value of -2 to the x value of 3. Notice that we cannot include those because right here is neither negative nor positive. Right? Alright, let's do about two more of these examples. So if you guys go to page 24 and write this down, pause it, write it down. We're going to talk about where this function's positive and negative as well. Alright, so let's talk about this again. So when you guys are looking for the... Oops, sorry. This won't move. What values of x make this expression positive or negative? Again, x means we're thinking about like our domain. Well, positive means where are we above the x-axis, negative means where are we below the x-axis. So if that's the case, then we just need to figure out when we're on our x-axis. Again, notice that both of these are in intercept form. So we can find our intercepts by setting -2x plus 6 equal to 0. We want to know when is x 0. What values will give me this 0. And then x plus 5 equals 0. Alright, so this basically means we're making y 0, figuring out what x is. So if you subtract 6 from both sides, I get -2x equals -6. If I take this and I divide by -2, so I'm solving for x right now, I get that x is +3. Over here, I just need to subtract 5, and I find out that x is -5. So this means my x-intercepts will be at positive 3 and the x value of negative 5. So positive 3 can be about here, and so we'll label that, and negative 5 can be about over here. It's just a sketch. And then I need to pay attention to whether this function opens up or whether it opens down. So look back at this first term right here. This is going to give me a negative 2x squared, which is how I know that my function is going to open down. So that means I actually want to draw it like this, facing downward. Okay? Alright, so where's this function positive? Positive means that I'm looking for where my function's above my x-axis. So my function's above my x-axis, starting at the x value of 5 all the way to the x value of 3. So from the x value of negative 5 to the x value of 3, do not include those. And then it's actually negative this time in 2 places. Alright, it is negative from the x value of negative infinity all the way to the x value of 5. It stops. So from the x value of negative infinity to the x value of negative 5. And then union, because there's another one, starting at the x value of 3, going to the x value of positive infinity. So from 3 to positive infinity. So positive in one place, this one interval, and then negative here, and then negative here as well. Alright, see if you guys can do another one. Why don't you guys write this on? Hopefully you have room on this page. If not, find another page. See if you can do this one on your own, and then unpause it and listen to the explanation of where you can go with this. But see if you can find the x-intercepts, draw yourself a sketch, at least see if you can get that far. Alright, so let's find these x-intercepts. So we're going to take x minus 7, we're going to set it equal to 0. We're going to take negative 3x plus 4, we're going to set it equal to 0, all because these are in intercept form. So if I add 7 on both sides, I get that x is 7. Over here I have to do a little bit more work. So I'm going to subtract 4 from both sides, and I get that negative 3x equals negative 4. I'm going to divide this side by negative 3. And then I get that x is, and don't freak out, I know this isn't a whole number, we're actually going to just leave this as a fraction. If you really want, you can put it as a decimal, but it's just that it's rounded, so I'd leave it as a fraction. So negative over negative makes it positive, so that just means this is at 4/3. Alright, so here's my xy axis to help me out. Let's sketch this. So one of these is at positive 7, so I'm going to put that all the way over here. And then this one's at 4/3. 4/3 is a little bit, this is about 1.3 repeating. So that means it's a little bit bigger than 1, so it's about here. And again, I'm going to leave it as 4/3, which is what we prefer because it's not rounded, it's exact. Pay attention to this term right here. This gives me negative 3x squared, so that means that this function opens down. So I again want to draw it like the last one where it goes like this. Alright, and again, we're looking for my x values that make this function positive, meaning where's my function above the x-axis, and then where's my function below the x-axis. Before you start, you should kind of have an idea of which one is going to have 2 intervals. It's below my x-axis here and here. So that's 2 places where it's positive from this x value to this x value. So, let's see. So I'm positive from this x value of 4/3 to the x value of 7. So from 4/3 to the x value of 7. And then I'm negative from the x value of this x value starting all the way on the left over here at negative infinity, all the way until it hits the x value of 4/3. So from the x value of negative infinity to the x value of 4/3, it stops being negative, starts being positive, and then at the x value of 7, it starts being negative again, all the way to the x value of positive, all the way over here, positive infinity. So, parentheses again, and I have 2 intervals, so I combine them with this union. And there's my 3 intervals. Negative at 2 of them, positive at 1 of them. Alright? Okay, so this video is long enough without us doing the PBT and then example 4, so we're actually going to move ahead. Right, so your homework was given to you guys on either Monday or Tuesday before you left for Thanksgiving break. It's called Worksheet 3.1. If you didn't grab it or you lost it, your dog ate it, whatever reason, remember that it's on the Google Drive. If you go to, should be you. If you go to your Math 2 student folder, go to Worksheets. We're in Unit 3 now, and Unit 3A, and then it's this right here. It's 3.1. So it looks like this. Okay, so in the beginning, you're going to do some stuff from both sections, um, simplify, and then here's what we just talked about, right? Sorry. Here. I don't know why this won't stay. Here's where you're going to identify where the expression is positive or negative. So you're going to do this 4 times. Pay attention to whether things are positive functions opening up or negative functions opening down. Okay? All right, so that worksheet needs to be done when you guys come back to class on Monday. We'll have some time Monday to go over some questions on that worksheet before we start a new section. And then Tuesday, we start factoring, which we're going to spend a lot of time on. All right, so thanks again for watching this, guys. Hope you had a good Thanksgiving. See you Monday.